Hi everybody, my name is Oliver Klein and I'm a solutions architect with AWS focusing on emerging technologies. Today we will talk about the exciting space of natural language understanding and automated speech recognition using Amazon Lex, one of our newly launched services in our Amazon AI offerings. But first, let's recap the history of how we interface with computers. In the early days, the only way to interface with a computer was with the help of punch cards and shifting memory registers around. Frankly speaking, not the most user-friendly way of operating with a system. The next generation introduced the concept of graphical user interfaces, where we suddenly had pointers, sliders, or other graphical elements to interface with a machine. Indeed, a major improvement. And as of now, we are slowly transitioning, with the help of artificial intelligence, to using written and spoken natural language to interface with our applications. The ability to use our normal way of speaking or typing text into a messenger to fulfill certain intents in an application is much more natural for our end customer to use. It also makes us often much more efficient and definitely more accessible for users that might not be familiar with the latest graphical user interface components. So why aren't we surrounded yet by tons of conversational interfaces in our everyday life? Building conversational interfaces comes with a variety of challenges for developers, from understanding and parsing natural language, understanding speech and context, or making sure we have scalable and highly available systems to react quickly, and this is where Amazon Lex comes in handy. Now, Amazon Lex allows any developer to build conversational interfaces using natural language understanding and automatic speech recognition, and integrate them with their applications using simple API calls. By the way, these are the same deep learning models on which the Alexa voice services are built on, the voice services that power devices like the Amazon Echo. Amazon Lex provides us with a simple user interface in the AWS Management Console, which allows us to build intent-based conversation. We can extend any of the conversations by fulfilling our own logic by triggering an AWS Lambda function, and Amazon Lex also supports multi-step conversations. Oh, and by the way, it's of course also fully managed. This will work both for written text, think chatbots, as well as spoken language, which we can record as audio files and then have interpreted by Amazon Lex. We'll start with a high-level picture of the structure of a Lex bot first, and later we'll demo the Lex console and create a bot for Facebook Messenger. At a high level, there are two basic components of a Lex bot. First, we need to understand a user's input. The user's input is mapped to two components. Firstly, utterances, a predefined list of potential interpretations which we use to train the speech model, and slots, which are like variables populated by user input. From these, we call it an intent. You can think of all intents like functions. They represent an action a user wants to take, depending on the input received. The second component is fulfillment. This is business logic of your bot, which handles the intent and works out what the response should be. As we'll see later, you can use AWS Lambda functions to make this incredibly flexible. Let's take a closer look at the utterances and slots first. First, we define certain intents in Amazon Lex of possible user interactions. These could be things like book a hotel, get a taxi ride, pour a coffee, or any interactions which you would like to have with your customers. In a single Lex chatbot, you can define many of those different intents, and the intent that resembles best to the user's intention will then be triggered. All you need to do is provide Amazon Lex with some sample utterances of typed phrases that could indicate the user's intent. For an intent to book a hotel, these could be utterances like, "I'd like to book a hotel," "I want to make my hotel reservations," "Can you help me book my hotel?" "I want to have a hotel room in New York City." Amazon Lex will now trigger this intent when a user will type or speak something along those lines. This is not an exact matching, so a few sample utterances is sufficient for Lex to know what you mean. Next, you can specify slots. These are additional information which you request from the user before being able to fulfill the intent. In the scenario of a hotel booking, this could be slots like which city or which state you would need this room and for how many nights. Amazon Lex also allows you to define what kind of data type you're looking for in this input. It will provide you with default types, but you can also create your own types and provide us with sample utterances to define this type. Amazon Lex will automatically extract the slot out of the user's response. So the user does not need to respond in single words. Let's say our user would respond with, "I want to stay in New York City." Lex will then extract New York City as the destination slot. Now, to ask for those slot information, we can tell Lex how it should elicit this slot. So for the destination slot, we could define a question like, "Sure, what city do you want to book?" Now, once we've mapped the user inputs to an intent and all required slots are defined, we then need to create the output for Lex. We can define simple responses or pass the intent and slots to AWS Lambda to handle more complex business logic. AWS Lambda, as you'll be familiar with, can integrate with both AWS and other services. For example, if you're ordering a pizza, you might need to integrate with your store's API. If you're integrating with a build system, you might make a call to your version control system, and so on. In our own example, when a user books a hotel room, we might want to update the database with the booking details or contact our ERP system. At the end, AWS Lambda returns the output to Lex, which then forms a response for the client. Let's go into a little more detail about how Lambda function hooks work. When a user engages with the bot, Lex parses the user's input and extracts the relevant information. This is given to Lambda as an input event. On screen is a partial schema for the Lambda input. You can see that the Lambda function is given the intent name and slots, so your function can use these to define what to do as inputs come slowly in. You can then write an AWS Lambda function to handle any calls to services and creating a reply to the user. Then, for Lex to return this reply, you must pass it as a response object from AWS Lambda. On the screen, we can see another partial schema for the response. Some important things to highlight are the intent name and slots as before. The message is what Lex should use to create the response to the user, either as text or audio. We also return a type of dialog action. This can take one of a few string values, and it's how we can control the conversation flow based on things the user has set. Elicit slot means we might want to prompt the user for a slot, which is specified as the slot to elicit value. For example, say we look at the booking date slot and it's actually invalid because, hey, there's no available room anymore on that date. So we need to prompt the user for that other date again. Confirm intent means that the Lex bot will expect the user to respond with a yes or no answer. Close means that the Lex bot will just return its output and not expect any more input. In the case of Facebook specifically, you can also tell Lex to return a response card. This is useful if you want your user to select something from a list of options. Say you need to elicit the event date slot, as in our previous example. You can give the user a list of valid dates, and then they just need to click on the button to respond with the new slot value. In Lambda, we just add the response card key to our response object. We can define the title, subtitle, any images, and the buttons to display. Amazon Lex also allows you to easily deploy this chatbot now to mobile apps using our mobile hub, and that would include speech recognition. Or you could deploy it to a third-party platform like Facebook Messenger, as already mentioned, Slack, or even Twilio, if you want to enable SMS-based bots. This intent can of course also be triggered via voice instead of only text, which would be the scenario of a chatbot in Facebook. Here we see an overview of a full flow-through of a book a hotel intent. Output such as the confirmation that the room has been booked can also be rendered in voice with different voices which are available through the Amazon Lex service. As we keep iterating on our intent, it is also important to note that Amazon Lex allows us to version all of the intent changes we are making. This also allows us to easily roll back to a previous version if our newest update might not work so well. Before we publish the skill out, we can also specify an alias and map that alias with a version. This is useful to create a development, test staging, or production intent, for example. Talking about publishing, when we save an intent change within a bot, we first need to build this new version. This will create the necessary underlying natural language understanding model based on the slots and utterances which we specified. We can then test the bot, and if we are satisfied with it, publish it to our live environment, such as, for example, our Facebook chatbot. To make sure we have a good user experience with our bot, it is important to measure the success rate of correctly identified utterances. Or more specifically, monitor how many utterances we missed and what the request latency was. Amazon Lex provides you with these metrics for every version you build, which allows you to improve your intent version with better utterances if the misses are too high. And that's it. We created our first chatbot that understands natural language. Now it is for you to think about what could be possible with such bots. Maybe you create your own informational bots that help you get weather or news updates. Application bots which allow you to book tickets or order food. Enterprise productivity bots that could check marketing performance or inventory status. And of course, IoT bots, where you could think of how to enrich wearable devices or appliances with speech recognition and natural language understanding. And what are some of our customers saying? Capital One, one of the largest retail banks in the US, is thrilled about Amazon Lex. They say, as a heavy user of AWS, Amazon Lex's seamless integration with other AWS services like AWS Lambda and AWS DynamoDB is really appealing. They also note the potential decreased time to market for a new generation of voice and text interactions with their customers. HubSpot also noted how their growth bot helps marketers and salespeople to be more productive by providing access to relevant data and services using more conventional interfaces. They used Amazon Lex to provide a more intuitive interface for their users and tap onto advanced AI and machine learning models without having to code those algorithms themselves. All right. Time for a demo. Let's have a look of how we could use Amazon Lex to create a Facebook chatbot, which would allow us to apply for a credit card through Facebook Messenger. Amazon Lex will ask for the relevant information, such as date of birth and name, and we will then fulfill the intent with an AWS Lambda function. This function will store the application in Amazon DynamoDB and notify our operations team via our Slack channel. Now, let's try this out. So let's have a look now at how we would do in our Amazon Lex console. Now what you see here is basically the console of Lex linked up with a credit card application bot. Now we already created one intent here, which we called the apply credit card intent. Now in this intent, we want our customers to basically apply for a credit card. So the first thing that we need to do is we need to define certain utterances of what people are likely saying when they want to apply for a credit card. So what we chose to use here would be apply for a credit card, get a credit card, or receive a credit card. Now, as mentioned earlier, you actually don't need the exact matching when somebody types it in. So just provide a variety of utterances of what you think people would tell you, and Amazon Lex will slowly learn, based on those utterances, what will trigger this intent. Now the next thing that we need to do is we want to have some additional information that we want to get in. Here the slots will come in handy. So we want to know the person's name, his birthday, his education, etc. So how do we do that? Well, basically let's look at the slots here on our console. Here we put in a variety of slots. And on those slots we define name, city, phone number, birthday, and education that we're asking for. How are we asking for this? Well, basically, we want to ask for it with the questions that we defined here. What city do you live in? What's your phone number? Etc. Now, all of these fields are marked as required. Now, as you see, currently, I cannot edit these kind of slots. Why is that so? Well, because I'm currently on a version that is not the latest one. As mentioned earlier, all of the bots can be versioned. So let's try to change this version. For this, we will go up here, click on this box, and say Latest. This will allow us to edit all of the slots and utterances to create a new version that we can build for our bot. Now, if we go back to our slots, you can see that I now am able to actually change some of these components. So you see that for the name, we, for example, chose one of the predefined Amazon slot types. Here specifically, Amazon.person. Now for education, you see that I actually didn't use a predefined Amazon slot. We built our own slot, which we called Education Degree. How does that work? Well, you can define your own slot types if any of the Amazon default slot types are not matching what you're asking for. To do so, you click on slot types here on the right side on the little plus button. Now I did that and educated Education Degree. Let's have a look at the slot type. Now as you see, the slot type functions similarly to how utterances work. You will provide us with a variety of sample values that this slot would look like, and then Lex will learn based on those values what would be the correct type. Now, if we now ask our user in our chatbot later on what educational qualification that person have, only if he answers with something that matches the type of what we trained the slot type, then the bot will move on to the next slot. If it is this last slot that it tries to fulfill, it will then try to fulfill that intent. In this specific scenario, we chose to fulfill the intent using a Lambda function. Now, as mentioned earlier, this Lambda function will store this information in a DynamoDB table and also notify our operations team via posting a message into our Slack channel. It will then respond with a goodbye message, which we see down here. Thank you, name, and this is filled with the person's name. Thank you for your interest. We will get back to you soon with the next steps. Now, if you don't want to hard code this message in here, you can actually also have the Lambda function return this goodbye message or follow-up message as such. If we're happy with all of this, we can save our intent by clicking on Save Intent. After doing that, we created a new version that we can then build. If we build a version, we just need to click on the Build button here. If I'm happy with this, I just need to say, is it a child-directed kind of chatbot that I'm creating? Yes or no. In this scenario, it will be no. And then I just submit it to build it. I click again on Build here. And now my skill will be, or my intent will be built. What this is doing, based on the information that I provided Lex, it will now train a model that tries to understand what people are saying, tries to fulfill the slots with the utterances that you provided, and then will fulfill this using AWS Lambda. Now, as mentioned earlier, we want to integrate this chatbot now with Facebook. How do we do that? Well, if we look at our tab here, we actually see that there's a Channels tab here. If I click on Channels, you see the different kind of integrations that Lex currently supports. So here we would have Facebook, Twilio, which is great if you want to have an SMS chatbot, or Slack, and there are more to come. In this scenario, we opted for Facebook. If we want to connect this for Facebook, first what we need is a Facebook page. Now let's switch over to my Facebook here. I already created a page earlier, which I called the Demo BankBot page. Now, to enable the ability to actually programmatically read and talk to the Facebook API using their messenger capabilities, we need to create a Facebook app. How do we do that? Well, we can go to developers.facebook.com and create such an app. Let's have a look at this. On my tab here, I have the developers.facebook.com interface, and I already created an application which I called the BankBot. Now, in that BankBot, I enabled two different products. The first one is the Messenger product. This allows our application to actually read and write from the Messenger capabilities of that Facebook page. Now, I also want to integrate that with Amazon Lex. To do that, we need webhooks. As you see here, I also enabled another product, which is called webhooks. Now, the webhook allows us to have a certain URL that gets called on every message update. And this URL will be Amazon Lex. Now, how do we tie that back up? If we click here on the settings page of the Messenger, we will find that we can create a so-called page token. We select the page that we want to have, in this scenario the demo bank bot, and it will create a page access token. Now this token will allow us to actually access our Facebook page with this Facebook application. Now if we have a page access token, we need one more additional information that we need to fill into Amazon Lex. We'll find that under Settings. If I click on Settings, I will find the application ID. In this scenario here, I will also find the app secret. Now if I click on Show, I need to enter my password first here for verification purposes. And it will then reveal the application secret. Now important, this is an application secret, so do not share that with anyone. This is the information that you actually will use to give Lex the permission to talk to the Facebook application and then talk to your Facebook Messenger. Now with those two pieces of information, we can navigate back to our Amazon Lex console. If you're on our Amazon Lex console, you can see that in the Facebook channels page here, we can now integrate this by typing in a certain name, defining the different alias of our chatbot, providing a certain verify token, and this one will become important when we hook it back up with the Facebook webhooks. And here we see the page access token and the app secret key that we should now have copy pasted in from the page and just shown you. After we've done that, we click the Activate button. This will provide us with a callback URL, which you see down here. Now that endpoint URL is the URL that we will use for the webhook on the Facebook page settings. So I'm going to go ahead and copy this over. What we can do now is navigate back to our developers page. Here we will now again click on our Messenger product, but in this scenario we will scroll down to webhooks. As you see, I've already enabled this, but let's just click on Edit Events to see how that would look like if you enter this manually yourself. If I click on Edit Events, I can define the different kind of events that I want the webhook to send to my Amazon Lex. So in this scenario, I want every messages, every message postback, and every message opt-in. I will also then enter the callback URL very much here, and you also find that under the webhooks settings here. Let's click on webhooks here. On webhooks, you can see that I can actually edit the subscription. Let me edit the subscription. And here we have the link up. Here is the Lex URL that we're calling, and here is the verified token that we just entered earlier in the Lex console before we activated this together. Now, if we're happy with all of this, we can go back to our Messenger page and then make sure that our webhook is subscribed to the correct page. In this scenario, the demo bank bot. All right, that's all we require. So let's try the skill out. I'm going to navigate over to my Facebook, and I'm going to start chatting with my demo bank bot. How do we do that? On a Facebook page, we can scroll down to the contact details here, and we'll find a send message button. If I click on this button, it will actually open up the chat to directly chat with this Facebook page. So let's try this out. I want a credit card. And there we go. Our Amazon Lex bot now starts to respond. It identified an utterance that was similar to what we gave it, and it knows now that we want to apply for a credit card. So it called the credit card intent. Now, the first slot needs to be filled. So it asks us, what name would you like to be printed on your credit card? Well, that would be Olivier Klein. All right. What city do you live in? Well, I actually do live in Hong Kong. What's your phone number? Well, how about this? Well, that doesn't look like a phone number, so what's your phone number? Well, 1, 2, 3, 4, 5, 6. There we go. That looks more like a phone number. What's your birthday? Well, here we generally want to have, as a developer, a very nicely formatted way of writing a date, like this, 9080 #07 #01. Realistically, nobody will type that in. Everybody will probably just say, hey, 1st of July 1980. Now Lex will automatically understand what you're writing and later on pass it into the right format that we want to have as a developer. So let's say this. It will respond again to us. What educational qualification do you have? Well, I do have a master's degree. All right, we got all the slots filled, and now it will confirm if we shall submit our credit card application. I think so. So let's say yes, please. The complete intent is fulfilled. It called the AWS Lambda function. It returned a goodbye message of thank you with the name. Thank you, Oliver Klein, for your interest. We will get back to you soon with the next steps. And you already heard it in the background. It contacted my Slack API to push this message or this information also into Slack. Now let's have a look at our Slack channel here. And you see it came through. Our credit card application bot tells me new credit card application from Oliver Klein has been received. Now our operations team can pick up from here. And hey, by the way, you saw it also correctly pass the birth date into the format that we prefer as a developer. So a great way to kind of quickly build a bot that has natural language understanding, full integration with Facebook, and it allows us to create a Facebook page that is highly responsive to our customers' requests. If after today you're wanting to take your AWS knowledge to the next level, you have several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Additionally, you can attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And finally, don't forget to validate your technical expertise with AWS and use practice exams to help you prepare for AWS certifications. Finally, I would also like to thank you for attending this session today and sticking it out until the very end of the presentation. Please take the time to provide feedback on today's event so that we can improve the event experience for you in the future. Thank you.